So today we're going to be doing a Unit 1 review, operating with positive rational numbers. And you need to make sure that you're paying attention and you are prepared for the quiz questions that are going to appear throughout the video. These questions will show me your results and help me to identify areas that we might need to study even further before our Unit 1 assessment. So good luck and happy studying. We talked about this a little bit at the beginning of the year, where we're going to be able to use our bouncing ball method to start at the 4, bounce down to the 3, and then back up to create the numerator in our solution. Then we're going to start at the 5, bounce up to the 2, and back down to create the denominator in our solution. When we cross our bouncing balls, we make an X in the middle, which reminds us that we need to multiply, not divide. So 4 times 3 is 12, and 5 times 2 is 10, which will give us our solution, which is 12 tenths, or simplified 6/5, or written as a mixed number, 1 1/5. Any of those answers would be acceptable. We do want to practice simplifying usually, though. Mixed numbers. A mixed number is just a number that has is a fraction, but it's written with whole numbers attached. So I have 1 1/3 divided by 2/9. In order for me to use my bouncing ball method, I have to change my mixed number into an improper fraction. An improper fraction is something like 6/5, where the numerator is greater than the denominator. In this case, I have one whole number that is represented in thirds. In order to create one whole, I need 3/3. But I've already got 1/3, so I need to account for that as well. So 3/3 and 1/3 together would be 4/3. And I'm going to rewrite my problem, divided by 2/9. Now I can use the bouncing ball method just like I did when I am dividing regular fractions. So 4 bounces to 9 and then back up to my numerator, while 3 bounces to 2 and then back down to my denominator. The cross in the middle reminds me to multiply. So 4 times 9 is equal to 36 in my numerator. 3 times 2 is equal to 6 in my denominator. This could be my solution, 36/6. That is an improper fraction. Or I could simplify it to 6/1 and get myself a whole number answer, which is just the value 6. Let's start out with the multiplication problem. Multiplying decimals includes multiplying like you would normally multiply a problem, but accounting for the decimal places. So let's solve this problem here. 2 times 8 is 16. 2 times 0 is 0, plus 1 is 1. 2 times 0 is 0. Bring down a 0. Because I have a 0 here, every time I multiply by 0, it's going to equal 0, so I'm going to skip that step. And my solution is going to be 0, 1, 6. However, I have 1, 2, and 1, 2, 3 decimal places in my factors. So I need to count all those decimal places up and insert them into my solution. So I have 1, 2, and then I'm going to have 1, 2, 3. Which gives me a final solution of, this is the tenths place, hundreds place, thousands place, 10 thousands, 100 thousands. So I have 1,600 thousandths. That is my solution. And go ahead and rotate on to my next problem, which in this case will be the division. Division problem is similar to multiplication because you do it in the same algorithm that you would do standard whole number division. But first, you have to account for the decimal points. So in my problem, the first thing I'm going to do is shift the decimal point of my divisor over so that I have a divisor which is a whole number. However many places I shift the decimal in my divisor, I have to also shift it in the dividend. So I need to insert my decimal point there. I'm going to take that point and put it up in my quotient right away so I don't forget that that's where it's supposed to go. Now I just divide. 21 goes into 46 twice. 2 times 21 is 42. I do my subtraction. 46 minus 42 is 4. Bring down the next number, which is 5, and divide again. 21 goes into 45 twice. It's 42. Subtract. Bring down my 8. One more time. 21 goes into 38 once. 1 times 21 is 21. I do my subtraction, so I have 17 left over. I can continue this by adding a decimal and say how many times does 21 go into 170, but I certainly do not have to. I'm going to rotate my template one more time so that I may work on my addition problem. Adding decimals is very simple because we just add the way we normally add whole numbers. However, we have to be sure that the decimals are lined up. We have to account for all the place values. So as long as my decimals are in the same place, we won't have a problem. If you are missing any digits, for example, above my 8, I do not have a digit here, and I need one, I just insert a 0. This won't change the value of my equation, so it's totally okay to do that. Now I'm going to add. 0 plus 8 is 8, 6 plus 1 is 7, bring down my decimal, 3 plus 2 is 5, 1 plus 4 is 5, and I have a final answer of 55 and 78 hundredths. Once again, similarly to the addition, subtraction is very straightforward as long as your decimal points are lined up. So 4 minus 7 is impossible, so I need to borrow from my 6. 14 minus 7 is 7. 5 minus 8 is impossible, I borrow from my 8. 15 minus 8 is 7. Bring down my decimal point. 7 minus 8 is impossible, I borrow from my 3. 17 minus 8 is 9. 2 minus 0 is 2. So my final answer is 29 and 77 hundredths. I would like you to find the GCF and the LCM of two numbers, and we're going to use the numbers 30 and 42 in our example. And the way we're going to do this is we're going to use the ladder method. Now the ladder method starts like this. We draw kind of an L with a very long tail on it, and we put our two numbers inside that L. So we're starting with 30 and 42. And then we think to ourselves, what is a common factor of 30 and 42? And it can be any factor. It can be the biggest factor, it could be the smallest factor, it could be just a factor that comes up off the top of your head. So the factor I'm going to choose is the number 2. And once you find that factor, you're going to put it exactly where I put my 2, kind of to the left-hand side. And you're going to think to yourself, okay, if I factored 30 by 2, what would I get? Well, 30 divided by 2 is 15. We're going to do the same thing with the 42. If I factor 42 by 2, I'm going to get 21. Now we're going to draw the next layer of our ladder, and we're going to repeat what we just did. So again, I'm going to look for a common factor. It can be any factor. The one that jumps out at me is the number 3. 3 goes into 15 5 times, and 3 goes into 21 7 times. Now, when I look at the numbers 5 and 7, I don't see a common factor. I've kind of run out of room here, right? So are there any more factors? No. There are no more common factors. So I'm going to stop right here. And what I'm going to do is change tools for a second and jump to a highlighter. And I'm going to draw an L using all of the numbers outside of my ladder. Okay? Now here's the kind of trick for you to help with your memory. GCF, LCM. I just drew an L, which means I'm going to start with the LCM. The LCM is going to equal to all the parts that exist in the L that I just drew. The 2 times the 3 times the 5 and times the 7. So when I multiply all those numbers together, 2 times 3 is 6, times 5 is 30, times 7 is going to give me 210. Guess what? 210 is my LCM. So my LCM is equal to 210. Now, I'm just going to look one more time. Rather than looking at the whole L, I'm going to look at the vertical numbers. And that's going to be my GCF. So my GCF is equal to 2 times 3, which is just 6. And now I know that my GCF is 6. So that was my Unit 1 review, operating with positive rational numbers, which included dividing fractions, decimal operations, and GCF and LCM. Hopefully this will help you prepare for your Unit 1 test. Keep studying!